So you need to understand statistics and what statistics can tell you. One, to draw a reliable conclusion from data, and two, to really be a well-informed member society. You have statistics thrown at you all the time, and you really need to understand what it is, what can be said, and the limits of statistics. Um, Through this PowerPoint, you will be able to click through each slide. So it's not going to be timed. You should be able to click through each slide, and there should be audio with each slide as well. This is everything you need to know for the next quiz. All these terms will be bolded throughout this PowerPoint, and it will be mostly definitions, and it will most likely be more than 10 questions in order to give you an opportunity to make more points and improve your score. I'm not going to read through this example, but this is the example the textbook gave. Most statistics textbooks that I looked for were business statistics, and this was the only textbook that I actually found was statistics for engineers and scientists. So the population, say if we're measuring salamanders, the population would be the entire population of salamanders within a certain area or within the United States. Um, it's really impossible to measure every member of a population, so we instead measure a sample. We measure what we can find, what we can catch. If this is talking about people, with this is a census year, so the population would be everyone within the United States, and the sample would be the people that actually get interviewed. They pick their sample by a method called a simple random sample, which ideally broadly is broad enough to where it represents the sample actually represents the population. So sampling variation is an effect that you see if the sample is not homogeneously spread out throughout the population. If you are polling politics and you happen to sample in a majority Republican state, you might get a different result than if you were to sample in a majority Democratic state. Or if you're asking questions in a rich neighborhood versus a poor neighborhood in response to social justice and things like that, you might get different answers. So sampling variation is just something that kind of occurs. That's why you want to spread your sample evenly across the population so that you get a good representative sample of that population. So types of data, we have what is known as quantitative. You think quantity, something that is associated with numbers, something we can assign a numeric value to. The other type of data is qualitative, which is more categorizing things. They can fall into one category or another. Usually if you've got a number of some sort, it is quantitative, and qualitative is usually, again, like it's a categorical. Gender, race, how you're voting, whether a Republican, Democrat, or independent. Those would be qualitative values. So a controlled experiment is one in which the experimenter controls values for the different factors that they're studying. This is an experiment that is designed from the beginning, and a lot of the experiments that you see within laboratories or even out in the field are done this way. It usually gives a cause and effect relationship between the factors and the effects that are seen. An observational study, where it's often done after the fact, and a lot of medical studies or observational studies, or referred to as anecdotal, where they go back through the literature and associate things. It's not usually as reliable as a controlled study, but it's still it's oftentimes done on things that are unethical to change or control within a human population. All right, with summary statistics, we are basically trying to get a set of numbers that characterize our sample. And we start off with a mean. A mean is what you typically know of as an average. And standard deviation as well as the variance gives us an idea how spread out the data are from that mean. So to calculate a mean, it is the sum of all the numbers in our sample divided by the numbers in our sample. And sometimes the mean is, lies right on one of our sample numbers. If you see our first set there, where our mean is 20 divided by 5 equals 4. 4 is one of our numbers. Sometimes the mean is pulled to one way or another by an outlier. If you look at the set of numbers, 50 is a lot larger than any of the other numbers, and it pulls our mean to 10.8, which is above any of the other number sets. Or any of the other numbers within our set that gets pulled sometimes by an outlier. So the mean by itself is not always useful. That's why we have all these other numbers to kind of go with it. And again, standard deviation and variance, they both determine how spread out that number set is from the mean. If you just know the definition, standard deviation is the square root of the variance. The variance is the standard deviation squared. We will calculate the variance in the next lecture, and just know the two by definition right now. Don't worry about how you actually calculate them. So an outlier, like I just said, is a point that is much larger or much smaller than the rest of the sample points. Sometimes they're real, sometimes they're not. Sometimes it's error, sometimes you just have a really tall person in the class if you're measuring height, and he or she would be the outlier. So sometimes the researchers will run statistical calculations with the outlier, and sometimes they'll run it without the outlier, and basically look at the two sets of data. But oftentimes it's real. Other times it's not. It's just an error. The median is the middle number of an ordered data set. If you arrange your data so it's from smallest number to largest number, the median is the middle in that set. So if you have an odd number of values, the median is the middle value when you order them. Again, you order them from smallest to largest, and in this example, the median would be 4. You have 5 values, 2, 3, 4, 7, and 9, and the median is the one in the middle. Remember, n is the number of values you have. If you add 1 to that to get an even number and divide by 2, that will give you the position of your values. So we've got position 1, position 2, position 3. So your median is 4. If you just think of kind of dividing it in half, where's your midline with those numbers? So if you have an even number of values, your median will actually be the mean between the middle two. In this case, you would have n divided by 2, your number, so in this case it's 6, we have 6 values here. So it would be n divided by 2, which would be 3 in this case, and n divided by 2 plus 1. So it's the average or the mean between the numbers in those positions. So we have position 3 and position 4, so that would give us 1, 2, 3, and 4. The average between 4 and 7. In that case, our median would be 5.5. We just add 4 and 7 to get 11. Divide by 2, 5.5. So the calculation of the median is a little different between having an even and an odd number of values. So the mode is the most frequently occurring value in a sample. In the example I give you there, you have the mode is 4. It occurs 3 times. And the range is the difference between the largest and smallest values in the sample. The range, kind of with the standard deviation of variance, tells you how spread out the data is, but it's just the difference between the largest and the smallest number. A dot plot is kind of a rudimentary histogram, but it's basically if you arrange your numbers in a linear fashion, each dot would represent the number of samples that you have in that category. As you can see here, there were 1, 2, 3, 4 samples that measured 51, and a bunch of samples that just came right in order from the mid 60s to the mid 70s, and then you had 1, 2, 3, 4 that were like 74 or 75, and then 1, 2, 3, 4, 5 that were 76 in value. It's not entirely useful, but it does give you kind of an idea of how spread out the data is. Again, it's kind of a rudimentary histogram. So histogram, again, gives you an idea of the shape of the data. You probably know this as a bar graph, but I'm sure you've seen histograms before. So I'm not going to go through how to create a histogram. You can kind of read this on your own. But again, once you look at it, it does kind of make sense. So an example of a histogram, you have the values on the x-axis and the frequency of the values on the y-axis. And if you notice, it says relative frequency, and it is calculated in tenths. It could be percentages, or it could be the raw data, just the sheer numbers of the occurrences. But here they have relative frequency, which is telling you the emissions in grams per gallon. There were 20% approximately that fell between 1 and 3 grams per gallon, slightly less than 20% fell between 3 and 5 grams per gallon, and almost 30% fell between 5 and 7. So that is what that's telling you there on the y-axis. Again, sometimes you can have raw data, or you can calculate the frequency of the data to set everything to like a proper zero mark. Think of our dialysis experiment where we calculated the percent change in weight. That's all that's doing is setting everything to a 100%, out of 100% type of frequency. But basically on the x-axis you have the classes of the values where they're going to fall, and on the y-axis you have the actual the frequency of those values, how many measurements you got within that set of values. So a histogram, that is, you've probably heard of a bell curve where you want your teacher to curve a grade. That is basically what you're looking at here. This is a symmetric histogram. A bell curve is kind of a line, but it follows what's referred to as a symmetric histogram. When you look at the mean and the median, the mean, again, the average of the values, and the median is that middle value. They're usually fairly close to each other within a symmetric histogram. And this is kind of what, if you think about the bell curve, what this tells you is that most of the occurrences fall about in the middle of the range. As you go towards the left side, you have less and less occurrences. As you go towards the right side, you have less and less occurrences. So if you were to think about this as far as grades, very few people in a class get A's, very few people in a class get F's, but most people get in the middle, about the C range. And this is what you refer to as a unimodal histogram. One mode, you've got one peak. So when you get a skewed histogram, this is what's referred to as a right skewed or positively skewed histogram. If you kind of think about what you've got, you have a bunch of individuals that are in the kind of in the left side, and you've got a few that are really, really far out, kind of outliers in a way that are on the right side. So if you think about this as grades, and you have a lot of people that have done kind of poorly, and you have a few people that have done really, really well, assuming a low score is on the left side and a high score is on the right side. And in this situation, your mean is greater than your median. So those outliers out there pull the mean towards their side. Okay, the median, remember, is the middle number. It means you've got a lot of values that are below the mean, but you have a few values that are so high above the mean that they pull that mean to be greater than the median. So this is a left skewed histogram where you have a lot of people got a really good score on the exam, and some people got such a very, very low score that it pulls your average down. And again, your mean is less than your median in a left-handed skewed histogram, kind of the opposite of a right-handed skewed histogram. And again, both of these, the left skewed and the right skewed, are just like the symmetrical histogram. They are all unimodal. Okay, they've got one mode, or one peak. And again, the mode would be the most frequently occurring measurement. That's the one that's very high in this example. So bimodal would be something kind of odd where, again, if you're using the analogy of grades, a lot of people got Fs and a lot of people got As, but very few people got Cs. So if you think about the mode, the most frequently occurring number, say a lot of people got in the 30s and a lot of people got in the 80s. Very few people got in the 60s and 70s. This usually represents subsamples. If you're thinking, if you're measuring things out in nature, that's kind of different than what you see in the class grade wise, but the way I always think about this in grades, if you see bimodal results on an exam, you have a bunch of people who are really prepared and a bunch of people who were just totally not prepared. So either you knew it well or you didn't know it at all. I hope you guys got a little bit out of this. This is kind of new for me for recording PowerPoints, but if you have questions, by all means, email me and we'll get it figured out. But hopefully on the next quiz, you guys will have everything you need to know. Again, go back, no bolded terms, and just know them by definition. And hopefully this helps. Thank you much.